Boolean logic is a branch of logic that where we look at specific statements, okay, and we'll combine multiple statements that are either true or false into some expression that is either true or false. Now, this expression could just be something as simple as just statement one and statement two. They both have to be true, or it could be something that's much more complex, something like an implication or a relationship among the statements. So um, there's lots of different things that go on. One of the ways that we approach logic, Boolean logic, is actually through sets. That's a good way to kind of think about statements. And so in connection to sets, a search is true if the element is part of the set. So a very simple example would be something like some dogs are black. Okay? And this is a simple statement, and then we have sets here. We have a set of black things, and we have a set of dogs. Okay, and since some dogs are black, we would have a set where a portion of the dog circle is contained in the black circle. That's just an example of how you can use sets to represent a statement. So let's look at just a basic conditions here, and think of it in terms of sets, and then we'll just describe the numbers that meet the condition. So here we want even and less than 10 and greater than 0. So we have to think about there's three different sets that we're considering here: even, less than 10, greater than 0. Those three sets. So the even set is, well, there's all the even numbers. There's an infinite number of them, but I'll just write it like this: dot dot dot, -4, -2, 0, 2, 4, 6, and so on. Okay. There's the less than 10 set, and numbers that are less than 10, well, there's an infinite number of them, and I can't really list out the elements like this because there are, even the decimal or fraction numbers like 0.3421, would work. But I do have less than 10. What I will do here is, because I know that I need even and less than 10, I know that I'm not going to be looking at decimals anyway. So I'm going to go ahead and say, well, less than 10 I could think of as everything from 9, 8, 7, and down forever. Now, again, this doesn't contain everything, right? There's a ton of there's lots of numbers between 9 and 8, or between 9 and 10 even. But this is just an illustration of that. And then same thing for greater than 0. Greater than 0, we have the set, well, not 0, but we could have 1, 2, 3, and so on. Again, this does not contain everything. The way I've written this pretends like I'm just looking at integers, but that's not the case. If I wanted, I could change the statement here. Let's just describe the integers. That way this is accurate. Now I've got these different sets, and so to meet the condition of even and less than 10 and greater than 0, I'm looking for where I've got numbers in all three of these sets because of that word and. And so looking at this then, okay, well, I've got even numbers. They have to be greater than 0, so I can't have any negatives. And so I can only look at things greater than 0, so starting at 2. So I get 2, 4, 6, and I can keep going. However, I also have this condition less than 10, so I'm not allowed to go to the next even number, which is 10. And so this here is the set described by this statement or condition.